So I'm just going to make up a p-value and then say, if the p-value is this, what would you conclude? And I think that will be, hopefully we can do that. So, all right. So, okay, blind taste test. Alka wants to understand if there's a difference in preference between the 3 chewable vitamins among men and women. They select 146 men, 162 women. They allow each person to sample all 3 vitamins. For each individual, Alka records whether that person prefers brand A, B, or C. Alka wants to see if the preference is different for men than it is for women, which hypothesis that should be. So here's the way this is going to look. If this was the test question, what I think I'm going to do is I'm going to say A, which hypothesis test should they use? B, what is the null and the alternative? I only asked 3 of these questions, but I'm going to ask 4 here. I think that's tough. C is going to be what equation should you use, should you pick? And finally, given a p-value of, and then I'm just going to make up a number like 0.13, what is your conclusion? Okay. So, so given this, even before you answer the question, what hypothesis test should you use, what question should you ask yourself? Categorical, quantitative, or regression? Right?
Categorical.
Okay, so I'll give you categorical. How many vote for categorical? 1, 2, 3, 4, 5, 6, 7, 8, 16, 17, 18. How many say quantitative?
Sure.
Somebody's got to be the contrarian. Okay. How many people say regression? That's obviously not regression. Okay. Why did you pick quantitative? What did you pick? Quantitative. You picked quantitative. Why did you pick that?
Not sure.
Just to be contrarian. Okay. Yeah, this one is categorical. Okay. So very good. Now it says what hypothesis should they use? Let me give you some choices. Okay, of all the categorical tests, what are your options?
Z, T,
Okay, so let's be a little bit more specific than just Z, because we got more than one Z, don't we?
1, 2 sample proportion.
We got a 1 sample
2
portion, which is Z, and we got a 2 sample Z independent, and we got a 2 sample Z dependent. And what else do we have?
T.
Do we have a T?
Yeah, 2 is T.
We have a T on that categoricals, do we? No, there's no T on this one.
No, chi-squared.
What else do we have?
Chi-squared?
Chi-squared. Let's be more specific. Independent and chi-squared. Goodness. Fit. Any others? All right, should we just go through them all? Or do you guys want to guess? Here, I'll let some of you make your case.
2 samples.
Okay, what do you got, Cassidy?
2 sample Z independent, because it's between the men and women, and they're independent from each other.
Okay, so 2 sample independent. Cassidy?
I say
Nope.
Chi-square independence because?
because we don't have the same information for the population, and because we're seeing if their preference is independent of their gender.
Okay. Any other choices? Any other cases? The Cassidy twins disagree on this one. Okay, so should we go with those two choices? Okay, so who says two sample Z independent? 1, 2, 3, 4, 5, 6. Who says chi-square independent? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Who voted twice? Who did not vote? You got it wrong. Okay. All right. Majority wins. We'll go with the chi-square independence test. Okay. Now Cassidy kind of did a little bit of a scattershot thing. Some of the things she said was correct, and some of the things she said didn't matter. Can you repeat what you said?
The first part didn't matter.
First part didn't matter. The second part did. It was because.
Because you're testing if your preference is independent of your gender.
Okay, she didn't repeat what she said the first time.
I don't remember.
Now, my other class actually voted with the other Cassidy, and they said it was two sample proportion. That was the majority in their case. Okay. Now, why is it not a two sample proportion? Let me ask that. Let me ask it that way.
Don't know the standard deviation.
There's no proportion.
Well, you could calculate proportions, though, right?
Yeah.
I mean, if you had data, obviously I'm not giving you data, but you could calculate them, right?
We don't know the standard
Okay.
deviation, right?
We don't know the standard deviation. That's true. That's what Cassidy said, but that doesn't matter because we can always figure that out. So it's on a categorical test, we can figure that out. So here's why it's not a two sample proportion. We've got three chewable vitamins. Okay, that's not a binomial anymore. You're getting to choose between three. You got three choices. It's not, can't be a binomial. Can't be a proportion test. Okay? So that's why it's got to be an independence test. Because of that. Okay? Does that make sense?
How do you decide if it's between the vitamins or between the genders?
Because you only got two genders, right? But those two genders have to choose between the three vitamins. So it's the three is the thing that matters. Okay? I've got three choices. Okay? It's not just two choices. Okay? It's not the vitamins picking the gender. Okay? All right. So, given that we know it's a chi-square independence test, what should be the null and the alternative hypothesis?
And then D equals 0, T doesn't equal 0.
D equals 0? Anybody disagree with that? Cassidy, should we?
Isn't this the one where you say if it's independent or not?
Oh, yeah.
Yeah.
Yeah, it's an independence test, although two proportions said independence too, right? But yeah, this one should say independence and does it say dependent? No, it's independent. Okay, now, I would like you to be a little bit more specific, so that's the general thing, but let's be a little bit more specific. What's independent of what? So vitamin prep is independent of gender, and the alternate will be exactly the same, except for what's the difference? Not independent of gender. Okay? All right. So, what equation should you pick for chi-square independence test? Yeah, you can look it up. Obviously, I'll give you a formula sheet for that.
The sum of observed minus expected squared over expected.
Sum of the observed minus expected squared divided by the expected. Okay, plus you're gonna have to figure out the expected count, right? Which is another formula. But this is all I'm asking about right here, okay? So you plug that in, you do everything, you do all your work, you have real data there. You get a p-value of 0.13. What is your conclusion? Okay, what's your alpha?
0.05.
We'll assume it's 0.05, I didn't give it to you, right?
Okay, so.
Okay, so I got a p-value. Let's go a little slower than what I'm gonna ask there. P-value equals 0.13. We're gonna do my alpha equals 0.05.
And it's
What would you normally do?
Don't reject.
You do not reject,
So,
and therefore your conclusion is,
Gender is independent of taste.
oh, yeah, we can see that. You can see it on your alternative, okay?
Arizona evidence claim that vitamin preference is not independent. Oh, yeah.
Okay, I think I heard an independent, I heard a not independent. What's concerning me? Okay,
You do not
so I think, Tim, what did you say?
Independent.
You said what's independent?
Vitamin preference.
Vitamin preference is independent, and Jacqueline, what did you say? You say not?
Independent, yeah.
Okay, so should we vote? Here, I'm gonna write it, so vitamin preference is, and then I'm gonna put, it's either independent or not independent. Gender. Okay, so who says it's independent? Definite majority. Who says it's not? Oh, you changed your mind? Who says it's not independent? Okay, so you changed your mind. That's correct. It is independent of gender because we are not rejecting the null. So that means the null said it was independent. We're not rejecting that, therefore it must be independent. Or there's not enough evidence that it's not independent. Okay? It's a lot easier when you're doing it with a group, right? Can you do this on your own?
No.
Okay, so here, let me do, we've got a few minutes left. I'm gonna try to do one more example. We'll just do the next one. I'm gonna copy all these things here. We're gonna do number 5. I'm gonna erase this answer because it may or may not apply, and that may or may not apply. And we'll get rid of this, and that, and that. Oh, that's okay. Get rid of that. Okay. So, Winton University requires their students getting a degree in physics to take the physics GRE as a condition of graduation. That's mean. Okay? It's been the policy for about 40 years. Recently, they've offered a degree in physics to distance learning students. This year, 18% of their students in the physics program are distance learners. As the percentage rises, Winton University's administrative and overhead costs are expected to decrease dramatically. Department chair is curious if the distance learners are getting similar scores on the GRE as their traditional students. He's treating the average score of traditional students as the norm and wants to test the average of the distance learners against the norm. Which test should he use? Now, before you answer that question, is this categorical, quantitative, or regression?
Quantitative.
Quantitative? Anybody disagree and say it's categorical? There's a percent in there, right? This is it's a proportion or a category. I mean. 1. Okay, I didn't mean to steer you wrong. It was quantitative. There was a distractor in there, though. Okay. All right. Okay, so if it's quantitative, what are my choices that I should pick? Let's talk about all the choices. Z, so let's be more specific. What kind of a Z? Z1, no, not a proportion because this is quantitative, right?
Yeah,
One sample mean.
Two samples.
Z, oh, is that a Z or is that a T?
That's a T.
A
T,
Two
T
samples.
one sample.
two sample,
T one sample.
independent, T, one sample, T, two sample dependent. What else is there? We could do a chi-square standard deviation, right? Okay, make your case. Which one is it? Somebody besides the Cassidys. Okay, so Jacqueline said one sample mean t-test.
Yeah,
Oh, I swear I wrote that once, didn't I?
you did, you put two T.
One sample T right there. Anybody else have a case?
Well, aren't there two samples?
The
Means?
traditional and the visual.
Yeah.
Yeah.
Somebody besides Cassie's supposed to say something, but I'm glad she said something. Okay, two sample T, we'll go with Cassie, even though she wasn't supposed to talk. That was a good suggestion, actually.
Oh, I see.
Any others? Ashley, what do you think? Two sample independent? Well, it could be a dependent, right? Ooh, those are hard to do, those are easy to screw up. Should we just go through, or we're out of time?
Let's
Really
go
quickly.
through.
Z one sample mean, who says? Okay, that's correct. Who says two sample independent? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That's a big one there, okay. Who says T one sample? 1. Who says T two sample dependent? 1. Who says chi-square standard deviation? Okay, we're going with majority wins. It's the two sample independent. Okay, really quickly, what you know in your alternative hypothesis in this case?
New.
mu1 equals mu2. mu1 does not equal mu2. Okay, what equation should you pick?
Population mean.
It's the one with the x bars. X bar 1 minus x bar 2, blah, blah, blah. Let's change your p-value. You got a p-value of 0.02 this time. What would you conclude?
Reject that hoe.
You'd reject the null, which would mean
that they do not equal each other, the means
there's
don't
enough
equal
of
each other.
significant evidence. If I actually gave you data, could you tell me which one was higher?
Yeah.
Yes, I gave you data. Okay? All right, these are really good. And 3 of them are gonna be on your test.